Hi, I'm JK from SSW TV, and here we are live at NDC Sydney. And here we have Daniel Chambers, Senior Consultant at Redify. So we have here a couple of questions for you, but first, why should we care for F#?
So I think there's a number of reasons why people should look at F# as a language they use in their day-to-day work. Of course, it's a .NET language, just like VB and C#. So it's a relatively easy step across if you're already working in those languages, because you can use all the same libraries that you're used to. So if you've got a favorite library, it's still .NET, so you can still call across to that. But the big difference between F# and a language like C# is that C# is an imperative style language, whereas F# is a functional language. And what this means is that it enables you to write code in a more functional way, so with using functions as first-class entities, unlike C#, which gives you some of that, particularly in the newer versions of C#, when they added things like lambda functions. F# has those things as first-class features in the language. So, for example, F# lets you curry functions automatically, so it will basically break a function down into its smallest definition, so that you can basically partially apply it, create functions by calling it with only some of its parameters, and it returns a function that takes the rest of the parameters. And what those sorts of features allow you to do is write code that's very compositional. So you can very easily reuse and combine code together. So you focus on making functions that are small, and you combine them together into larger function calls, larger functions, combining them together, and yeah, your code ends up being a lot easier to read. A couple of the other features that make F# really nice is that it supports immutability. So when you define your types in F#, by default they're immutable. So once you make for example, you make a record which contains a bunch of fields, they end up being immutable. So you can't change it, which sounds like a restriction if you've never played in immutability before. You're like, oh, that sounds painful. But in reality, F#, being a functional language, gives you the tools to be able to deal with that. So it's very easy to modify a record, but you're not actually modifying it, you're just creating a copy with a value changed.
And it also improves the parallel processing, right?
Exactly, and that's like parallelism is one place where immutability can really be of benefit. So if you've ever done multi-threading code, you know that you've got that race condition issue where you've got some shared mutable data structure and you have multiple threads acting on that thing, and they can trip over each other, do things in unexpected orders, because it's all non-deterministic once multiple threads are involved. And it's pretty easy to get yourself into a tangle, and it's extremely difficult to reproduce it. Whereas if you have immutable types, you basically eliminate that problem straight out of hand, because you just literally can't change a thing. Two threads will look at something and they will always be looking at the same thing, and because it literally can't change. So it forces you to write code in a very different way, but again, because F# is a functional language, it helps you do that. So when you write functions in F#, you generally try to ensure that those functions are pure functions. What that means is that they take input, they return output, and they don't do any side effects. So if you're writing C#, it's very typical to write a function that just returns void and does a bunch of stuff. And if you're used to that, that seems very natural. But once you start writing more functionally, you realize it's kind of an anti-pattern in a way, because it makes it very difficult for the person who's looking at that code, having no idea what's actually going on in there, to know what that thing is doing. Whereas when you have a pure function, it's very easy to tell what that function is doing if you look at its type signature, because it has input parameters and it has an output parameter, and since there can be no side effects, then you can see that it takes these things in and it returns this thing out. And so a lot of the time you often don't even have to lift the corner of the rug and see what dirt's underneath there. You just look at the types and it tells you what it does.
That makes it more testable, right?
Oh, definitely. Pure functions are sort of inherently testable. One of the challenges when you're writing unit tests in a language like C# or other imperative languages where mutability is all over the place is, your methods may just change some random thing over here, and then you find out, oh, well, you know, it's modifying some static variable, and then if I run my tests in a different order, maybe they break. That's not a problem when you've got a pure function, because that function is not able to change anything. Like it can't mutate state anywhere else. It can't modify, you know, static variables somewhere. It simply takes input, does some work on that, and returns output. And if you pass in the same input, you always get the same output, because again, there's no external forces, there's no outside state on these pure functions that they can mutate. So because of that, like natural reproducibility, where you put in the same input, you get the same output, it's super easy to unit test, because you put in your input, say, what's the output? Is that what I expected? Yeah, cool.
Yeah, it's like math and equations.
Yes, and that side of things is where functional programming sort of has its roots in mathematics. And you know, I guess some people look at that and they go, oh, didn't like maths in school, maybe I won't like functional programming. And I think it's important to understand that while the basis of functional programming is in mathematics, you don't have to be a mathematician or even good at maths to be able to do functional programming. It's no different to when you learned how to do imperative programming in university, or maybe you taught yourself. You know, you can teach yourself functional programming just in the same way. You know, it can be different, but it's definitely very learnable, and you don't need to have some crazy math PhD to understand it. I think one of the good things about F# is that because it's a .NET language, it sort of gives people a nice on-ramp into functional programming, where they don't have to go fully into you know, all of the things that functional programming does differently to imperative programming. F# is a hybrid language, so it supports OO constructs as well as functional constructs, which it kind of has to, because it's a .NET language, right? And so, you know, the .NET CLR has the concept of a class in it, so naturally F# has to have the concept of a class in it. So you can still write classes in F#, you can still call classes in F#. So, you know, all that interoperability is still there. And so if you're trying to learn a functional language, F# is a great choice, because you can still, while you're sort of putting your toe in the water, you can still write a class, you can still do mutability. It's not, you don't get mutability by default, but you can turn it on. You can use a mutable keyword and turn on mutability. But the language encourages you towards a more functional way of doing things, and so you can sort of bite off more and more of that as you learn you know, more functional ways of structuring your code. You can bite off more and more of that.
Yeah, and most of my friends know C#, but they have never developed for F#. So how easy would it be for them to include an F# code in their projects?
Yeah, again, because it's .NET, it's actually quite easy. So F# compiles down to a normal .NET assembly. So if you have, let's say, you know, you've got a C# application like most people do, or a VB one, and you've decided a particular part of the application would be better suited to be written in F#. Maybe it's something that does you know, some complex business rules, or maybe it does some particularly concurrent code. So you think the benefits of functional programming, you know, the expressiveness that it gives you, and the fact you've got immutability to help you with parallelism, you feel like that's a good piece you could cut off and you could write in F#. So you could create a new project in Visual Studio, make it an F# project, compile it to an assembly, and then you could literally reference that assembly from your C# project and call the functions inside of that assembly. It's pretty simple, with a caveat, right? So F# functions, because they're curried, as I mentioned before, they sort of get broken down into functions that return functions that return functions. They can be a bit awkward to invoke from C#. You can do it, it's just a bit ugly. So one of the patterns, if you're doing this, if you're trying to basically call F# code from C#, is in F# you'll create a class, like basically a facade class, and then in that you'll expose methods on the class that take parameters in the usual way that C# works, and then you'll call these functions, you know, the curried functions from that facade, and then you'll expose that, and that will be that class will be the facade that your C# code will use. So that way, you know, the F# compiler takes care of the plumbing of connecting the class and calling the functions in a functional way, and the C# consumer gets to see a C#ish style interface, and it's familiar, and your C# code is less ugly. So yeah, you've got that nice interoperability story there.
Okay, before the talk, you mentioned something about F-sharp scripting and fake. Can you
sure.
Tell me a little bit more?
Yeah, so F-sharp is a really good language if you're just trying to write a script. C-sharp has like an interactive, and there's you can run C-sharp as scripts now, but F-sharp has been doing that for ages. So you can basically create an FSX file, and then you can just pass it to the F-sharp interactive, so fsi.exe, and it will just run it. So you can use like #r up the top to reference assemblies, and you can just write code in there, and it will just run like a script. So F-sharp is really nice when you just need to, have something small that does, a few different actions. And unlike writing it in batch or writing it in bash or something like that, F-sharp is .NET, so you've got all your libraries, you've got all your type safety because it's a type-safe language. So your compiler helps you make sure that that code's correct. So doing your build scripts in F-sharp is actually not a bad idea. And there's an open source library that the F-sharp community has sort of embraced, and also you'll find a bunch of C-sharp guys will also use this library because it's quite nice. It's called Fake. So I think it's basically, if you've probably heard of Rake from the Rake community, their build tools, so Fake is the F-sharp Rake, right? So basically what it gives you is a library of functions that would be useful if you were writing scripts which were to do with builds. So it's got functions in there to invoke MS Build on projects, and rewrite your your version numbers in your assembly info files, and it's got a whole bunch of utilities for working with like copying files around on disk. Obviously .NET has those, but it gives you a better, like a more convenient way of doing it. And so you can assemble effectively targets in your fake script file, and then you run that thing, and you can have a build. You can have a build step, a clean step, a rebuild. So if you've gone beyond what like your default MS Build script is doing, and you're trying to do things that are more complicated, things that are suited to requiring a proper programming language, maybe you've outgrown what MS Build can do, or it's just too ugly to do in MS Build, then Fake is a really good choice, because F-sharp sort of gives you a very terse syntax that's type checked, so you can make sure that's correct. It infers a lot of types, way more types than C-sharp infers. You can sort of imagine F-sharp like it has the var keyword everywhere. It infers types for everything. You very rarely have to specify a type. It figures it out, which is really nice. So yeah, scripting is one of those scenarios that F-sharp really supports quite nicely. And so I think it's a good place if you're trying to dip your toe into learning F-sharp. One of the first places you'll start is just in a script file and just write a few lines of code and watch it run without the overhead of needing a Visual Studio project and all the rest of it.
That's nice to hear. Nowadays you're working mostly with Haskell, is that correct?
Yes, yeah. So at my current client, we're actually writing all of our code in Haskell, and our web stuff we write in PureScript as well, which is a Haskell style language that compiles down to JavaScript. And that's actually quite an interesting journey that we made on that team. I talked about it in a talk last year at NDC Sydney, and so we originally started off writing F-sharp, so we had all our code written in F-sharp, but this particular client, they run on AWS rather than Azure, and of course if you're on Azure, .NET is first class. It's very easy to run .NET on Azure, naturally, because it's Microsoft, so everything works together. But on AWS you can run .NET, but it's not a first class experience. It's kind of painful. You've got to run Windows VMs. There's a lot of infrastructure as a service overhead stuff that we were trying to get away from. So we sort of moved into the Docker container space. So we were looking, okay, how can we make our deployments much more easy? We don't want to be baking VMs, and copying files onto a VM and running them and setting up Windows services and all the scripting stuff that was really fragile and falling over quite a lot. We were like, well, containers, they seem like a good way of solving that deployment story. You build a container and then you just go run this container, and it contains a file system and it contains your application and it just runs. We're like, well, .NET can run on Linux. You've got Mono, so why don't we take our F-sharp application, which we were running on those Windows VMs, and why don't we put that in a Docker container and see how that goes? So we did that. We ran our F-sharp application on Mono, and unfortunately we ran into some really horrible reliability issues with Mono. And it's strange because we couldn't find anyone else who seemed to be having the same problems that we were, but like the Mono runtime would just segfault with stuff out of, like basically native code problems. So it's definitely not within our control, and none of us are, Mono developers or understand how the runtime works at a level enough to be able to debug that sort of crazy stuff. So we sort of got fed up with trying to deal with this. Luckily, the services that we were writing were like long-running data processing services that ran in the background. So for a while, we were able to limp along where occasionally, maybe a few times a day, they would crash with some seg fault, but then they would just restart themselves and pick up where they left off. So it didn't cause production issues, but it was annoying because you end up with errors in your logs, and it wasn't stable. You don't want an application that crashes and restarts as part of its daily life, right?
Yeah.
So we basically started looking around for, well, we really love functional programming, and we've written this F# app. We've embraced immutability. We've embraced functions. We're using a lot of functional patterns in our code. Where can we go where we can run on Linux? Because this was a few years ago, so there was no .NET Core. So, .NET Core was in work, but F# wasn't yet supported on .NET Core at that point. So we're like, well, where can we go from here if we want to keep writing functional code, but F# and Mono isn't working for us? Where can we go? So we sort of looked around. It wasn't very scientific. We sort of looked at, we had a bit of a look at Scala, and none of us really liked what we saw there. It was kind of it's a complicated language. It's a bit ugly, and it's on the JVM, and we weren't that enthusiastic. So when we looked at, we looked around at what seems to be what all the functional people demonstrate when they demonstrate a functional concept. What are they demonstrated in? Well, they demonstrate it in Haskell. So we're like, well, why don't we try Haskell? So this particular client, they have hackathons a couple times a year, which is awesome. So we basically got 3 days to do whatever we liked. So the team decided, well, why don't we spike out writing it part of our application in Haskell and see how that goes. Like if it's a bad experience, we'll figure out something else. So we took the core of our application, like the core logic for it, and we rewrote it in Haskell during those 3 days. And there were a number of team members, so some of us went off to figure out how do you do like web requests in Haskell, how do you do JSON parsing in Haskell, and all the usual stuff you do in your line of business programming and data processing back-end work. And so after those 3 days, we basically came out very successful. We managed to basically tick all the boxes. How do we read files? How do we do web requests? Can we rewrite our program logic? And it turned out that our program logic was actually in Haskell very similar to the code that we wrote in F#, because that core logic, we'd been very functional about the way we'd written it. The team was fairly functional, experienced in writing code in a functional way, so it was pretty easy to basically translate that into Haskell instead. So we were like, well, this seems pretty good. Like, we were quite successful, so we went ahead and we basically spent the next few months rewriting our application, which was very small at that point. So it wasn't like a huge application, it was a small one, because it was probably only a year old or something at that point, and it was a small team as well. So it was a smallish application, so it was reasonable to rewrite it. And so we rewrote it in Haskell, and so it probably took a few months. And then we put it live. We sort of ran it in parallel with the F# version for a while. It worked fine, very reliable, and so since then we really haven't looked back. Everything we've built has been on F#. We even had another service, on Haskell. We even had another service for a while there, which was limping along, running in Mono, crashing occasionally, and then AWS pushed a security update, and it basically broke that box. So something was not backwards compatible, so we had to upgrade to the latest VM image that Amazon provided, and it bumped up the Linux version, like the Linux kernel version for that particular image, which we didn't realize at the time. We figured it out afterwards, and unfortunately, whatever that change was in the Linux kernel, Mono didn't like that, and so it basically ended up crashing in a loop. So instead of it crashing maybe a couple times a day, it would basically start up, crash with seg faults and stuff. And we're like, so we had to sticks and glue that back to the old Linux kernel version, and then in a subsequent hackathon, we basically rewrote that thing in Haskell as well. And again, it's been super stable. So it's been an interesting journey, moving the team from F# into Haskell. Haskell it's a very complex language. At least there's a high number of concepts you have to understand, and particularly functional ones. It's not, if I had to recommend to someone, it's like, if you want to get into functional programming, where would you start? If you want to take it slowly, I probably wouldn't recommend Haskell, because to produce shipping software in Haskell, you've got to actually learn quite a few functional concepts that are very different to the way you do things in an imperative language. But F# on the other hand is much easier to get into because it's .NET. It's that hybrid style, so you've got OO there and you've got functional, so you can sort of you can have a toe in both sides. You can straddle that fence for a bit, and then I think over time, as you do that, you realise you prefer to be on the functional side, and you sort of move across. And maybe at that point, you take the same journey that I did, where it's like, well, I want more of this, and then you end up going into something like Haskell. So yeah, that was kind of our journey, and we've written some pure script as well, because we had to build a really small UI, not very complex, and we were like, I'm going to be writing JavaScript. Once you've worked in Haskell, and it has a very strong type system, like very strong. It's not possible to write mutable code at all in Haskell. It forces you to be pure. So once you sort of get used to that and you realize the benefits that it provides, the fact that you can trust the code that you look at, you're never going to open up a function and find out it's doing some dirty stuff, where it's like setting some global variable somewhere, which you can kind of do in F# if you're not disciplined, because it lets you have that escape hatch. Haskell doesn't. So once you're used to that guarantee, and you're used to just being able to look at types to see how things work, it's kind of hard to go back. So we were looking around, well, we want to write JavaScript, we have to write JavaScript, so how can we write it in a way that lets us write Haskell? And you've kind of got two options in that space. You've got GHC.js, which is the Haskell compiler compiling to JS, and then you've also got a language called PureScript, which is a Haskell-ish language, but it compiles to JavaScript. So probably wouldn't recommend people use that in production yet. It's still very bleeding edge. They're not yet 1.0, but for our very small UI, for an internal administration tool, it was an interesting experiment. I think it was fairly successful, but I'd probably say at this point it's probably too bleeding edge for most people to want to bite off, because we got bitten a couple of times where they made a breaking change and we had to go change a bunch of our code to match, to upgrade. So yeah, it's been interesting.
Yeah, sounds like a really interesting battle story.
Yeah.
Yeah, and with the .NET standard, do you think that you give another chance to F#?
Oh yeah, definitely. Like since we made that transition, F# and running on Linux has become a lot better. I guess for people for whom Mono worked fine, F#'s always been fine. But for some strange reason, that wasn't us, and I cannot for the life of me tell you why that is. Everybody at this particular client that used F# on Linux ran into that problem with Mono, but no one else on the internet seems to. So I don't know what was special about our little snowflake that caused the issue. But yeah, with the .NET Core and being able to run on Linux, that the F# story for Linux is looking a lot better for me now, definitely. So if I had to go to another client and they weren't ready to make a leap into Haskell, and admittedly that's a fairly hard sell for most people, I think. F# on .NET Core is actually quite a good option. So I believe F# is supported on the 1.x version of .NET Core, but it is missing some features. So there are some things they can't provide on .NET Core because of being .NET Core being that reduced API surface. There's certain things that F# needs that aren't there. The .NET Standard 2 ups that a bunch. So I think it was released a couple of days ago, and they said it was over double the number of double the number of APIs available.
Yeah, we're very excited for that.
Yeah, it looks like a big step up, which is great. So I believe F# will then be stepping up to start using some of those things. So I think some of the features that were locked off will probably open up. I think there's still things which aren't supported, even with .NET Standard. So F# has a feature called type providers, which basically allows you to have the compiler run something called a type provider, which generates types for you and then provides them to you so you can work with them. So the classic example is like, I want to do some XML parsing. So what you do is you give the type provider a sample XML document that looks like what you're going to be parsing, and it just looks at it, generates the types for you, and bang, you can just dot your way through it with IntelliSense and everything. It's nice. It's really, really nice. There are certain types of those type providers, types of types, that I don't believe are supported in .NET Core with .NET Standard 2, which is unfortunate. I'd like to see all of those things, because the type providers are one of those features that when people see it in F#, it's like mind blown. I did a talk a few years back on like why you should care about F#, and one of the last things I demoed was type providers in action. And one of the things you can do with it is you can pull in a type provider that will talk to your database. So you can write a SQL query, like just plain SQL query, in your F# file in a string, and the type provider will basically send that at compile time, send that query off to SQL Server, pick it apart, and then generate a type for you on the way back that says, well, you selected these fields, they have this type, here's a record type that exposes all of those fields by name, so you can dot out of that. So you can say, run this query, and it gives you automatically back a record with the right field names on there. So if you go up and change that SQL query later and maybe you rename a field, your code stops compiling because you changed the field name and now you need to change the code. It sort of eliminates that problem where you've got magic strings. If you were doing it in if you were doing it in a language like C#, you'd have those like a magic string where it's like, go to this data record and index in with this string for that field, and if you change your query, then it's broken at runtime. In F# you can have that thing checked with type providers at compile time, which is really, really good for maintainability. Like, it kind of, to some extent, eliminates a level of integration testing that you would have had to do manually by hand in C#, and in F# you don't have to do it because the type provider will do it for you at compile time. So it's super convenient. And it's super good if you're prototyping in a script as well, because you can just say, well, I'm going to do the SQL query from this database, and then dot, there are the fields, dot, and go off and IntelliSense your way to success, which is pretty good.
Yeah, IntelliSense for the win.
Yeah, definitely. Just control space all day.
So tomorrow you have a presentation about F#. Can you quickly tell us what's about?
So my talk tomorrow is about functional patterns. So it's a talk that mixes both Haskell and F#. Basically, over the last couple of years, as I've sort of been working in languages like Haskell, they've forced me to look at the fundamental functional patterns that things like features that you find in F# are built on, but they try not to tell you, or at least they don't make it obvious that those are the functional patterns you're actually using. So Haskell, because it's like a pure functional language, those are the patterns, and they're part of the concept count you have to learn when you pick up Haskell. So it forced me to learn those things. And there are three patterns: the functor, the applicative, and the monad. Everyone's probably heard of the monad. That one's the scary one that people go, oh, I don't understand monads. But it turns out, if you actually sit down and you have a look at them, you see how the types click together. You see a couple of implementations of the monad and the applicative and the functor. It turns out they're not actually that complicated, really. They just sound scary. So hopefully, in my talk tomorrow, the people who come will be able to benefit from the fact that I've sort of gone off and done the hard yards, sort of dug through that and figured out how they work, and hopefully I can communicate to them, kind of what I've learned and where those patterns are used even in C#. You'll find monad stuff in C#. It's just not called the same thing. It's got magic names. So like, the monad has a function called bind. It has a particular type signature. In C#, if you use select many, that's bind. They just don't tell you that. They just call it select many instead. And if you've got a functor, it has a function called map. It transforms values inside a structure. That's select from link. So if you're doing .select, or you're doing if you're doing link expressions, you're actually using functors and you don't know it. So yeah, it's interesting to sort of look back, having learned those patterns, and look back at where those functional ideas have percolated down into mainstream languages like C#, and even to a higher extent F# being a functional language. You find them a lot more in that language than you do in C#, and in JavaScript as well. So if you pick up the Lodash FP library. It contains a bunch of functions in there. Some of them are things that are very similar to those functional patterns. So you can get a map function for lists. You can get bind for lists. I think it's called flat map in Lodash because it flattens sublists into one big list. So yeah, it's interesting to look back and find out where those things have percolated down into everyday use and people aren't aware. So hopefully the talk will point out to people, it's like, you know, sounds scary, but it's not actually that scary. You've actually been probably using these patterns for a while and not even knowing about it. So now let's look at the formal definition of these things, see how they work, and yeah, hopefully it'll encourage people to maybe have a look at functional programming and see what other benefits it can provide to them beyond what they're getting now.
Yeah, that happens a lot, that you use patterns without knowing that.
Yes, yeah, definitely.
I'm JK from SSW TV, and thanks for watching.